MAGNOFLUX3D electric universe is here reviewed. The first picture shows to balance an electric universe requires dark electrostatic and electromagnetic forces. We show here 4 stars that are rotating a black hole. The top star on the right is in fact our Sun, and we have shown some of the planets revolving around it. The black hole is a magnetic hub at the very center. In reality, there are thousands or millions of stars in a galaxy, but all revolve the same magnetic hub. But notice that galaxies are broad sideways but thin in the up and down direction, more discus-shaped rather than spherical and homogeneous. The next picture we show is how we can get photons or magnons of inertia to spin through the volume of space effortlessly. If we take the right-hand one, the left-hand side of the magnet, which is plus, and it's also a North Pole, the other end is the South Pole, and they spin on their central axis. So you spin them through the left-hand slot and then back round the right-hand slot and round again, and they balance up so that there is no witness at the end of anything there at all. The next picture shows the electrostatic attraction across the solar system via DC voltage. Obviously, because we are all negative enclosed in electron shells, we're negatives, but the sun or stars are all positive. So they, to balance, have all of the positive charges and we have all the negatives. So there is a large voltage between our sun and its planets, which of course allows it to attract energy across the system to us. The next picture shows what rules how the photons can be absorbed into a molecule or reflected. So we start off as we did before with the left-hand side wave of inertia which comes in, but when it hits a piece of material, which we've shown here as a double pyramid, it can enter in or be reflected from, depending on its physical attributes. We see on the left-hand side Feynman's, on the right-hand side, we see Feynman's idea of quantum light, which of course took a huge amount of energy to produce because it's got electron particles in it. But when we come to MAGNOFLUX, that is totally energy free, and we can get the electromagnetic light through with very, very little loss. The next picture shows that domestic power is low frequency electromagnetic light. So Maxwell's rules apply to everything and all of it. We have shown here the light again is in the Z direction because that is where the voltage is, which is pulling the magnoflux area forward. We have amps in this direction on the X and flux, which is always exactly at right angles, in the Y direction. So they will produce a square inertia, which is moved forward by the voltage. But quantum light and VRs will reduce the 3D power by cosine of the angle xy to angle z. And we show here on the top left-hand side the original picture which you've got used to. But then if the voltage isn't exactly at right angles, then of course you get a loss because you've lost the volume in which you were going to put the power. So the power disappears and you get a cosine reduction in for power. We have done some demonstrations of the 3D spin using a CRT tube or a water cell, which you can look at some time at your own convenience. So the WMAP result shows gravity G is only a tiny 4.5% force in space, so the CDM model is inadequate. The MAGNOFLUX 3D hypothesis requires adoption of a fifth fundamental force in the universe. The magnoflux 2 pi spin force, which is some 6.28 times stronger than gravity, plus the electrostatic attractive or repelling force of 25 times the gravity force, which we call dark energy force. Also, all the equations concerning fundamental energy must have a cosine psi reduction angle incorporated in their formulas to explain the nature of the quantum units. Photon inertia power is equal to hf, which is Planck's constant of course times frequency, cos psi per second, or electrically it's volt times amps, cos psi per second. Multiple electromagnetic wave momentum, of course you just add up everything of all the different frequencies and all of the quantities and you will get the result you're after. Thank you very much for watching this presentation.